Hello, and welcome back to our second episode of Bioinformagic. Last time we talked about making a conda environment and storing it as a YAML file. On this episode, we're going to look at our continued exploration of reproducibility, this time implementing things with Git, which is the code repository way of storing and tracing through code to have it reproducible, but also track your changes as you move through a project, thus allowing you to go back, save things you need to save, and be able to share them in a reproducible manner with other colleagues, coworkers, contributors, collaborators, you name it. So to start out with, we have ourselves here. I'm going to go ahead and open a new terminal, as one does. Go ahead and clear some of that. So you can see on here that I have already had this folder called Bioinformagic. Where does that folder come from? Essentially, I have this repository here that I've made in GitHub. If I really want to, I can go back here. You can always go and create new repositories if you so choose. This one I am making available. It's public so that anyone can use it. You can go through the tutorials and the stuff that I'll put in here. I'll try and do a good job of organizing it. That way, if people want to go through different videos, they can kind of see what I did um, and just kind of look through it and get an idea, get a feel for the GitHub. And I'd recommend you doing the same thing. Make your own, follow through, keep up with the videos, and it'll help. And I'll kind of show you as we go through. So for the start of this one, if you're using VS Code on a Windows-based system like I am, it works a little bit differently than on a Linux-based system, mostly I think because of the Windows shell that's being used for Linux. So if you're using VS Code, it has a couple different things that are plugged in. One of them is called pull requests. There's also this source control. And you can see in here, I've already put this in as a repository. If you ever needed to, you could also create, say if I was going to make a new folder, we can call it whatever we want. Test source control. So that mkdir is make dir. You'll hear me say it that way. It essentially does exactly what it sounds like. It makes a directory in your file system. So now you can see here, I have a folder. If you want to check, you can do ls-la. This will give you more information. Also, in case you're wondering, since these are bytes, you can essentially go through and you can actually do a -h, which is putting it into a human readable format. And you can now see it in more of what you would expect in terms of, kilobytes and stuff like that. So let me go ahead and clear that. But now you can see here, what I can do is if any of these folders have any sort of Git to them, and what I mean by that is if I go into Bioinformagic and you do an ls, you're not going to see anything. You'll see the license and the README, but what I'm talking about is this. This is what we call a hidden folder. It's .git. This is basically what GitHub uses to track all of your changes. And what do I mean by that? If I go and I'm going to copy, I use ... to say use the directory above the one I'm currently in. And then from there, I'm going to take that bioinformagic.yaml. Oh, see, I didn't name it the way I thought I did. But this will show you, I can see everything above here. And as I actually named it bioinformagic-python, which is not what I thought it was. But do cp for copy, and then ... So say directory above me, and I want the bioinformagic-python. Also, what I could have done too, in case you're wondering, if you don't remember what it's called, but you remember the first part, I'm hitting tab twice, and when I do, it'll show me everything that matches that and expand on the different possibilities. This can be a little bit risky if there's a lot of files that are named kind of the same, so just something to be careful of. But if I do that, and then I have to tell it period, which is my current directory, and then you can put a slash if you so desire, but the period will also get it to where you want to go. Now, if I look at this, you now see that I have this file here, and I can now add it to my Git, and we'll do git add, and then Bioinformagic. And you should be able to also see it start popping up on these graphs here as I do it, but I think what I need to do first is git commit, and then realistically, there's different ways to do this. I can do -A, which is all changes, which is not what I recommend. You can also do it by file, which is usually better. If I just hit this as enter, it'll come up with a dialog box for me to type in a message. And that message gets displayed with my commit saying, what did I do? Realistically, this should be a one sentence description. Essentially, if you're getting anything past sentence and sentence, then your commit is too long, you're committing too many files. It's just a rule of thumb that gets used. So for this, I'm just going to say added my first Python YAML for Conda. Enter. We now see that there was one file changed, 44 insertions. If I go here, now you can see my initial commit. And then I can go sync changes. Okay. All right, and now you can see that that has been committed and pushed to my main branch. So now you can see on here, this is my main branch as it was, as you saw earlier. If I go here and I do a refresh from my main branch, that is our python.yaml. You can also see here, this is the message that I just used, and you can even tracks when it was done. This is a good start. And so from this, what I'm going to go into is show you what we're going to do next. So part of making this reproducible is not having everyone work on what we call the same branch. And you can see that here where it says like at main, that target is basically the branch that we're on. So I can do this where I can do git checkout. If I had a branch that already exists, I could put the name here. That will switch me to the branch that will be the one that I want to use. If I'm creating one, you usually put a -B and you can call it whatever you want. In this case, we'll put this as Docker because essentially our next step to make this reproducible is to start working with Docker so that we can deploy Docker containers and allow people to use them, which down the line we are going to integrate into a nextflow pipeline and show you how that all works so that you can start making your first pipelines. All right, and then I've now created this new branch, and then I can also then publish this branch. Yes, go ahead and create a pull request. And you'll see here it wants to do a merge into this. I don't need to merge anything as of yet. But you now also see that over here, I have this is now on Docker. And so if I want to, I could then start to make a Docker file. So let's go touch. I believe it also needs a capital, so Docker file. And go git add, Dockerfile, git commit, Dockerfile -m, added blank Dockerfile for next steps. All right, and then again, if I do this, now you can see here, this is from Origin Docker. This is the first Python module. So that's where we started from. That's where main ended. And then we started our new branch. You can see it's in a different color. And so from there, there's nothing in this file yet, but we can certainly create one. Essentially, the reason why Docker is used for a lot of these things is that Docker is a containerized system that allows us to share software packages, stuff like that, where it's already pre-built and ready to go. That way we could go through and essentially save the setup time. And as we were talking about making it reproducible, I can give somebody a conda file, that YAML to rebuild a conda environment. Um, but there's also ways to containerize the actual software itself so it lives in its own version and pass that around as well. That's what Docker and Singularity containers are meant to do. In doing that, we'll be able to then integrate them into our nextflow pipeline so that each step of our workflow will be able to use different software if needed, or if we have certain packages that are reused, say like Python, we can just call the same Docker container for many different parts of the workflow. And in doing that, make that reproducible as well. But we'll know that they're all using the same Python version and what packages are inside that Docker container. So next up, to make a Docker container, I can show you some examples. One that I have previously worked on. I'll open a new window. This is open source, so there's no secret soft here. Might be a small plug for a company I currently work at. In here you can show we have these different YAMLs the same way I'm showing you here. This is essentially what our Dockerfile is, which I'm essentially going to take a lot of this. We don't need everything, but rather than starting from scratch, just going to go ahead and copy that. This is open source, so I'm not doing anything that's going to get me into any trouble. But I will show you here if I go code, and this only works in VS Code. If I put in code and then I do Dockerfile, you can install that. That's just saying, do you want me to get this stuff for Docker? Pull this down here. You might be saying, why are you using this? And the reason is because I already have this set up and ready to go, so that it can already use the containers and things that I have already set up. So I'm going to take this out because this is not for them. The conda environment for this one is actually going to be called Bioinformagic -Python. The rest of these can stay the same. This first part here, the from, actually comes from Docker. So we're going to go to Docker Hub and see what version they're on. So if I go here and I pull this up, we can do Conda Forge, Mamba Forge. There we go. So recent tags looks like it's 24.9.2. So that's probably what we want to use. I might just use the full 24.9.0. This way I'm using a newer version of the container. Let's see. This would just be where is it installed to. essentially this is where it's going to copy it. So I'm just going to call this opt. This conda env is actually being used as an environmental variable. That's what we set up here as the arg. So what it's doing here is it's actually going to go and copy this. And when it's doing this copy, essentially what it's doing is looking at this here and saying, is there something that matches this from the actual directory in which you're running your Docker command? If so, move it into a directory that's called op/env, and then we're running that conda create env on that YAML, so it'll create our virtual environment in the Docker container. Do a little bit of cleanup, tell it to use bash as our basics, set up our conda, take out some of this, and we want to work in just that. This is just setting up some of our variables. So like this is where our path will be. We're adding this in there so it knows to look for it. We don't need to copy anything in there for now, but I guess we can just to have the license and everything. In case you're wondering, this is for time and date stuff that has issues. If you use any sort of text live, which we're not going to for this, I can go ahead and take that out. And then that's just our work directory. This one is a different issue for SAM tools that I can explain in a later one, but not an issue for us. Set our work directory back to where we need to be. I erased that other line because we're not changing any of those files, so we don't have to worry about that. And we don't need anything here either. Cool. So now we have this basic Docker file ready to go. I'm going to go ahead and save it. Notice up here it changed from a dot to an X, which tells me that I have made sure to save the changes. So now I'm pretty sure I don't have Docker installed. Yeah, so we're going to go sudo apt install. Actually, I think we can do sudo snap install Docker. Right. Actually, I don't know if I need sudo for this. I might just be able to do apt install. Okay, let's try this again. Docker build -t Python magic. just out of curiosity if I do it. Yeah. So there's some permission errors that I'll have to fix off camera. But for now, this will work to at least show you what it's doing. Essentially what it's doing is pulling from Docker Hub this Docker container, and it's creating a base image, and then on top of that it's going to copy our folder in and basically create our environment so that it starts our environment the way we would expect it to. It's a very small Docker container, so it should be pretty quick here. It is doing a little bit of updates. And it's telling us here that some of the stuff I'm using is now deprecated, so I'll have to change that. But that's okay, because once I show you how to change all that and how we use Git to track everything a little bit more, it'll be a good example of why we do this, because I can show you as we go through it, the changes that need to make. Now I can also check my Docker container. Notice that at the bottom of this, there is no execution or anything like that. It's just a container that has software in it. And so I can now do Docker run. Might ask me to do a sudo, but we'll see. The -it is to run it interactively. And then we'll do Python magic. Yep, that's what I thought. Now you can see it has all my stuff in here. You'll also notice that the environment here is already with the Bioinformagic Python on. And if I do Python, we should get our 3.13, which we do. I can exit out of this. The thing to understand though is even if I was to say touch and do some sort of myfile.txt, right? And I do an ls, you can see that txt file is there. Now if I log out, I guess exit, and then I go back in, you'll notice that that file is no longer there. When I'm running a Docker container interactively, if it's not added in this Docker build step, it's ephemeral. It no longer exists once I stop looking at that container. So that's important. That's why we only put our software in the files that we need, that we're going to use on every time we use this container. And we don't sit there and make it our file system. Now, going back to what we saw up here, this remote definition is deprecated. It's going to be removed in 25.9, so we got some time. But basically what it's saying is instead, it's talking about this one in particular. So it's 3.2 argparse. That's a future warning. And that's for essentially this part here, where we're doing conda.create env with that -f. Instead, what we should be doing, I guess, is saying is change this -f, and we're going to make it more explicit, and we're going to do file. I guess before I do this, let's go ahead and save that. I realize that if we look at this, go ahead and refresh. We didn't put the Docker container in yet, but now that we have our working Docker container, what I am going to do is show you on the source control. If I go git commit, as you can see, this is also good to know. You see it has root, and this means I'm in the Docker container. I'm going to exit out of that, and now I'm back where I want to be, which is my home computer in our Bioinformagic folder. You git add Dockerfile, and then git commit Dockerfile with a message. I guess I can show you the message without the -m. It opens up Nano, which is a text editor, and it basically says, please enter your commit message. It's going to be the same sort of thing. I'm going to be adding my first Docker container for use with Python. Voila. And then I'm going to do Control X. That's with that caret with the X next to it. I want to save the modified buffer. And it's asking me what format, which I don't really care. So I just say enter. Now it has one changed file with 40 things. So if I go here, I can now sync these changes. Okay, go ahead and push those commits. Normally I would probably do multiple commits at the same time, but I just wanted to show. So this is main. Now we're going to go to Docker. On here, you can see that I've added my first Python Docker. If I go, let's see, I should be able to refresh this. And we should see a Docker file, but I don't. Oh, there's our Docker file. I was just oblivious. But yeah, so you can see that this all works now. But now we're going to take up what they told us, which is this needs to be explicit now because the arg parse is going away. It's going to be dash dash file, which is what it says here. You'll notice that this basically gives us the error right after it's running this line, so we know that it's related to that. You can also see it's a future warning. Um, Basically, it's saying instead use this dash dash file equals URL, which in our case, I forgot the equal. And then we can also see here, if I go to the bottom and I do Docker build, yeah, you'll see something interesting happening with this Docker. A lot of these Dockers, what they use is layers to basically make the container. If some of your layers already exist, what it will normally do is go through and just detect which layers have changed. In this case, our base layer has changed with this first part, and so it's rebuilding everything. But if there's multiple different things being installed, then what will happen is it'll have multiple layers. If nothing has changed in those layers, it won't redo them, so it saves you time and makes things more efficient. So now that we've made sure that our container will still build, I'm going to do git commit and then Dockerfile. And on here, change to long form. And with this, I'll be able to say that we changed that dash F to dash dash file equals for Docker to use my Conda environment. And we'll go here. Normally I would do more of this in the actual CLI, so like git push would be usually what I would do. But this username authentication is having issues because of my setup on my system, likely because of security things. But that's also why you're seeing me do these source controls because it's already got an ODIC for my GitHub. And so it's saying wants to pull from origin Docker. Okay. And now we're up to date on this branch. We can also see that origin main has been left behind over here. And so eventually what we're going to do, since we have this working now, and this will be the last part of this lesson here, is create a pull request. So you see it says that this Docker branch, it's asking, do you want to put into main? We can call our pull request Docker for the first time. Adding Docker file to include my Python magic in a container for distribution. I create a pull request. And now you can see it includes all the commits that I've created since it left main. So basically it's comparing it back to it. You can see on here, the only difference is this one Docker file. You can even see what the commits are. You can go in here and say, okay, what did you change? In this case, basically it's the whole Docker file. I add an empty file. And then you can see this one. It's all added. And then lastly, you'll see it's still going to be just this one little bit that changed. Generally, it's good to have at least one or two people review it. Since this is just me, I could also ask Copilot. Copilot will go through and review it for you. In doing so, it'll find any issues that might have occurred. That way, you can at least have someone review your code, because unreviewed code is usually not great code. There's always ways to make your code better. So I'm going to go ahead and confirm this merge because I know that everything's good. And then I'm going to go here. My pull request is now gone, which is fine because realistically I don't have a pull request anymore, but you'll see that I still have two branches. It's just now that these two branches should match each other. And let's see here, we got a Docker file now that we're on main. It is our Docker file. It has the -- file that we just did. So we've now made some reproducible code that also creates a Docker container. And so with that, we are good to go, and we'll end our lesson here. Until next time, see you next week.